Hello everyone, welcome back to the latest lecture session. In the last session we started discussing about air pollution, specifically with greater detail or relevance to the Indian context, and I believe we were looking at some of the primary pollutants and national ambient air quality standards. So now we will move on and look at let's say one of the primary pollutants which is of primary concern to Indians. This obviously is particulate matter, right? I think it's been in the news considerably recently, and when we are talking about particulate matter, we are obviously talking about suspended particulate matter and fine particulate matter, PM2.5 and 10. So when we say particulate matter, what is it that I need to understand? We term that encompasses obviously dust, dirt, soot, smoke, and even liquid droplets, let's say, right, or aerosols, if I may say so. The small particles, I mean, why am I concerned with? Some pollutants obviously they can reach the or can be deposited onto the earth's surface, but small particles, they remain suspended in the air for a long time. So thus we are more susceptible, I mean, because of their perseverance in the atmosphere. The chances of we inhaling it and suffering from the adverse effect obviously are going to be relatively more. Some particles obviously are large enough to be seen, soot or smoke. Others are so small that we can't see them, especially without an ultron microscope, let's say, right. So let's move on. Again, primary particles and secondary. Primary meanings they are emitted directly from sources, right, and we are talking about sources such as power plants, construction sites, and so on and so forth. Secondary particles are and these are of considerable importance to us because they will affect our health considerably, is that they are formed in the atmosphere indirectly when gases from burning fuels or primary particles react with sunlight and water vapor, and after the relevant chemical reactions they are transformed into particles which we are referring to as secondary pollutants. We will look at what they are later, let us see, right. Again, let me skip the generic stuff. Well, definitions, you obviously do not need to mug them up, but you need to understand some of the relevant aspects because we will, or they are relevant to what do we say, attenuating them at the source. Solid or liquid particles with sizes from 0 or 10 power minus 3 to 100 micrometer will be in the air. General term is called aerosols. Dust is arising from grinding or crushing. Fumes are particles formed when vapors condense, let us say around dust, if I may say so, or you need some media out there. Smoke describes particles released in the combustion process, yes. And smog, this is of considerable importance to us, is used to describe or describes air pollution and is a combination of smoke, right, combustion products and fog, let us say, right. So that is smog out there. And let us just look at some of the relevant aspects that we are typically concerned about. Large particles, pollens, when it is at remarkably high concentration, yes, people are concerned because some have pollen allergies. But with respect to PM10, right, we have this, yes, PM10, cement dust, paint pigments, dust, and so on and so forth. Insecticide dust, this is a great killer with respect to air pollutants. Whatever can kill the insects and pests, I guess, will certainly kill us and lead to, it typically leads to cancer a lot. And then you have combustion nuclei and photochemical smog and such straddling both PM10 and PM2.5, 2.5, right, that is something we have. I believe I have a better picture soon. So Stokes Law, I guess, why am I looking at it? I guess it gives me the settling velocity, let us say, obviously depend upon the diameter of the particle, and it is the aerodynamic diameter, meaning diameter of the sphere having the same settling velocity of that as that of the particle, let us say, right. So that is, I guess, an indirect measurement out there, right. So if the velocity, not velocity, pardon me, if the diameter is less, obviously it will have a considerably disproportionate effect on the settling velocity, let us say, right. Again, we are not going to go into the Stokes law in detail. So here we have, let us say, two columns, one the diameter in micrometers and the time required to what do we say, settle. I guess the term should not have been sedimentation, but you understand from your water treatment or wastewater treatment that we were trying to settle particles, right? And when they did not settle, we had to use coagulation, flocculation and so on. So, time to move down 2 meter distance is given here, only 2 meters, keep this in mind, right. So, 100 micrometers takes 8 seconds, and dropping to 1, it takes to 16 hours obviously. It takes 16 hours to move down, what do we say, 2 meters. That too, this is the value in what do we say, when the atmosphere is quiescent, let us say, right. Obviously, when you have wind and such, it is going to increase or be affected considerably. 0.1, 27 days, and you see that it keeps on increasing, let us say, right. And one aspect that I want to point out with a good picture is this. This is from US EPA website. So, we have sand, fine sand, again keep that in mind, it is 90 micrometers, and human hair, the diameter we are looking at is 50 to 70 micrometers, right, diameter. And then we have particulate matter of size 10, as we mentioned, dust, pollen, mold, etc. When we say PM10, it is the particles of less than 10 micrometer diameters in size, or 10 microns, let us say, right, 10 microns in diameter. And then you can see PM2.5 as a bead on this PM10 particle, and then you will understand, like obviously compared to the diameter of the hair, what it is that we are talking about. PM2.5 or particulate matter of size 2.5 microns or lesser in diameter. So, combustion particles, obviously organic compounds and metals. So, this is what we are talking about, and this is remarkably, what do we say, a huge pollutant, certainly in the Indian context, because the concentration is very high, population density is also very high. So, what is happening, you have these very, very fine particles that are entering our body here. So, we will look at some information out here. Again, PM10 and 2.5, we already looked at this. So, I am going to move through this or skip this. So, chief culprits, from our discussion during the first few sessions of this course, we already looked at the primary culprits, but let us look at it in the context of India, I guess. So, what do we have out here? Other sources which are ill defined, but certainly industry, yes, one is for PM10, the other is for PM2.5. Industry, both cases considerable, and transport, right, combustion sources, that is why you see here again remarkable increase here too, right, biofuel too considerable, and what else, power, I guess, right, power generation, but I guess this is again, as I mentioned, with respect to India, where the data is typically not great at best. So, as we saw with respect to transport, it has a considerable effect on what do we say, PM10 and PM2.5 in India. So, we have different standards being given out for the vehicles at different points in time. So, for example, 2005, 2010 and so on and so forth. Bharat stage 3, Bharat stage 4, I think now we are skipping 5 and moving on to 6, right, different what do we say, kinds of emission standards are mentioned. And we have here PM2.5 pollution in India comparing to, let us say, I guess 22 years ago, right, to 2014, which is 6 years ago, right. Again, we just were looking at some comparative data. Again, as I mentioned, typically North Indian belt does not do well or was not doing well. That was in 1998, but now you see here the picture, I guess it has gotten worse all over India, with the remarkably affected zone now straddling what I think 30% of or 25% of the Indian population, right. You have the NCR out here, Punjab, Haryana, Uttar Pradesh and so on and so forth, let us say, right. And I guess we are going to see this ever worsening, and I am not sure when people will wake up, and hopefully you people will or the future, right, will play a role in this, right. Again, let us move on. So, we are talking about 80 to 100 micrograms per meter cube, which is well above the relevant what do we say limit here, or acceptable limit, right. So what do we have here? We have some other data here. 1998, 27% or about 27% of the districts are above 40 microgram per meter cube of PM 2.5. But here we see that it's a considerable increase to 63%, let's say, right. Again, this is data that we already looked at, where we know that the most polluted cities are typically Indian, let's say, right. And let's move on. And PM10 levels in 46 million plus, or the metro cities, I guess, in 2012. And here is the ESA standard, but again in India we increase this standard so that we show that more people are living in good quality air zones. Again, as you see, almost all the cities, I guess all the metro cities, so called metro cities, are 46 million, I guess million is 10 lakhs, right. So that is something to keep in mind. Okay. So again, we are facing the brunt of air pollution. And health effects of particulate matter, what is it that we have? Impact depends on a particle size, shape and composition obviously. Some are inert, some are not, shape and size, because they can enter the different, what do we say, respiratory zones or even the body. Here we have some information which is traditionally believed, but which has been disproven by, what do we say, recent data. Large particles obviously, as I said or mentioned, are trapped in your nose or nostrils, right. Particles greater than 10 micrometers are removed in the tracheobronchial system, but that is not really removed, they are deposited rather. So that is why when you have what do we say, high episodes of air pollution, let us say you typically have, what do we say, considerable issues with your throat or the tracheobronchial system. To say it is removed is maybe wrong, it is not going to remove it from the system, it is going to stop it from reaching the, what do we say, respiratory system, let us say, right, or respiratory zone. But obviously it will have its own issues out here. And this is what is contentious, though some people say that there is data, but this has been disproven if I am not wrong. Particles less than 0.5 microns reach lungs but are exhaled with air, but that is not true. Now we have enough data to show that. The much smaller particles reach our or go through our bloodstream too and are even deposited in our blood vessels, right. So that is something to keep in mind. And the particles between 2 to 4 micrometers are most effectively deposited in the lungs, right. In the lungs, the alveoli sacs and so on, which we already looked at, right. So health effects, obviously aggravated asthma, we saw that with the bronchial zones, I guess. Increase in respiratory symptoms like coughing and difficult or painful breathing. We saw that your alveoli sacs are going to be, what do we say, affected over time. So surface area, not enough surface area, so thus less transfer of oxygen. So you have greater difficulty in gaining the required oxygen, right. That is something we saw. And obviously that is what we say, relevant to decreased lung function. Chronic bronchitis, this is also something that we already saw, right. And obviously all these lead to premature death, let us say, right. It is like let us say human body is like a machine, I guess, in a way, and if you do not take care of the machine and it is going to chip away, or the air pollution or air pollutants are going to chip away at each aspect of the body, and it starts failing sooner and it does not work efficiently, and obviously it fails pretty it will fail sooner, right. That is what we mean by premature death. So other side effects, obviously visibility is an issue. Recently from our 2-story or 3-story house, we were able to see the lower Himalayas, right. I think maybe Mussoorie, if I may say so, but it is probably not Mussoorie, but the lower Himalayas. This was during the lockdown when there was no industrial activity, no, what do we say, transportation, right, and we are not sure which is the major culprit here with respect to air pollution. But even in Roorkee, which is relatively well off with respect to the air quality index, let's say, that shows that air pollution is an issue, right. We saw lower Himalayas for the first time in many, what do we say, decades, if I am not wrong, right. For example, in the civil engineering department, there is one picture from 1890s or 1870s, I guess, where we have a picture from atop the main building, which shows you a great view of the lower Himalayas. That I guess was never the case, and we saw that again certainly in or during the lockdown, right. So that is something to keep in mind. Other one is aesthetic damage. obviously, and also more maintenance and such is required. But more importantly, the plants are also going to be damaged because the particulate matter, they will form a thin film, right, and that obviously will affect your the photosynthesis of the plant. And here we have one particular article that I wanted to highlight, which was statistically rigorous, right. What do we have here? Attributable mortality density, or the deaths per area per year, right, deaths per area per year, let us see. And what do we have here in the North Americas? A, B, Europe and Africa, Northern Africa, and then obviously Asia, right. And what do we have? Dark gray regions indicate obviously areas without attributable mortality. We are talking about particulate matter 2.5 at 10 kilometer resolution, or we are concerned with premature mortality due to PM 2.5, let us say, right. And then I guess let us just look at the data. It is not, but you can go through the paper. It is remarkably relatively rigorous or vigorous. So what do we have here? Obviously, you can see that western part not really affected. I guess here we have Mexico somewhere out here, right. I think this is Florida if I am not wrong. So the eastern coast of US, yes, obviously relatively more industrialized, obviously has effects. But what can we say? 150,000, I guess, or 1,50,000 premature deaths can be attributed, but this is total of 610 million. Million is 10 lakhs, I guess, or 61 crores people, I guess, right, 61 crores, right. So that is something to keep in mind. And population weighted PM 2.5 is 12 microgram per meter cube. And here with respect to Europe and North Africa, we see that it is again remarkably high here, 6,80,000 attributable deaths, but here the people obviously are remarkably, what do we say, 160 crores, I guess, is what we are talking about, and concentration is 19 microgram per meter. And now we come to Asia, which as we have been discussing is always affected. We obviously clearly see the effect of air pollution, premature deaths. We are talking about attributable premature deaths, and the east coast of China, which is remarkably industrialized, right. And obviously what do we see out here? We see, I guess in that year, we are talking about it per year, I guess, right, 2,000-3,000, right. So crore, I guess, is it a crore? Okay, not really a crore, 2 crore, 23 lakhs, I guess, yes. Did I get something wrong? Let me just see that, 2,300 into 10 power 3, right. So that is what we have, 23 lakh deaths per year, but again this is a relatively lower estimate. Again keep in mind that we are talking about what do we say, this area out here. And what is the PM 2.5 weighted? It is 38, but in these sections obviously because of the population density concentration, it is going to be much higher. Again please keep in mind this is deaths in 1 year, and that is obviously remarkably high, right. So let me move on. So increasing cost and decreasing PM 2.5 emissions and decreasing manual labor. So that is something we see, and improving socio-economic status. As in the issue until, or even in India until very recently, maybe 10 or 20 years ago, was that indoor air pollution was an issue and outdoor air pollution was not an issue. Indoor air pollution because people did not have access, or the vast majority of the population did not have access to cleaner fuels. They had to burn, what do we say, solid matter or such, let us say, and typically soot, smoke and such is given out, carbon monoxide, carbon dioxide and such, let us say, right. So that led to considerable increase in, what do we say, or decrease in indoor air quality. But now with increasing economic status and access to cleaner fuels, the indoor air pollution is decreasing, and that is what we can see out here, let us say, right. People used to use dung, wood, charcoal, but now we are moving on to, what do we say, LPG, natural gas or electricity, and obviously that is why you see decreasing PM10. But what is happening now obviously conversely is that now your outdoor air pollution is remarkably high though. That is something to keep in mind, right. Particulate matter in the Taj, typically people look for symbols, and we have a symbol of various human emotions out here, right. It evokes different emotions in different people. Let me not go there. The deposition of particulate matter on the shimmering marble of Taj Mahal it gives a yellow tinge to the marble surface, degrading before our eyes itself, I guess, right. And carbon monoxide, it is the most abundant air pollutant, it seems, and it is obviously produced by incomplete combustion. And this is an issue because you would see piles of leaves or such, put up on the ground, and then people lit, what do we say, matchstick or lit a fire, typically to get rid of solid waste because they have no place to dump the solid waste or for warmth and such, let us say. But the issue is that you do not have obviously oxygen permeating through or being available to all areas of this particular fuel here, right. And what is going to happen? You are going to have incomplete combustion, right, and you are going to have release of considerable levels of carbon monoxide, right. So, again the people living there or right near that would have been would think that they are used to it, but it is not that they are used to it, but their primary sensors no more, I guess, are triggered by this repeated assault of or assault due to carbon monoxide or such pollutants, let us say, right. So, again insufficient O2, low temperature, obviously short time, and then poor mixing, again all are relevant. It is mostly due to incomplete combustion, let us say. And one other obvious major source in metropolitan cities anyway is motor vehicle exhaust, let us say. So, again keep your engine in order now, right. So, we have one way to calculate carbon monoxide in our, I guess, what is this? Effect of carbon monoxide on the blood, let us say. So, carbon monoxide, as we know, is colorless and odorless. When inhaled, it forms, what do we say, carboxyhemoglobin, which will reduce the oxygen carrying capacity. That is what it is that we are trying to, or people are trying to calculate here. I will not ask such questions in the exam though, but something to be aware of. The brain function is obviously reduced because your oxygen carrying capacity is not optimum. Heart rate is increased even at lower levels of requirement. Let us say heart has to, the pump has to function or beat at a heart rate, right. Asphyxiation occurs at higher levels, let us say, right, at higher levels of carbon monoxide, right. Again this is pretty straightforward. So, let me move on. So, what are the impact? I guess we have different thresholds and typically no symptoms at low thresholds and percent hemoglobin and exposure in hours. So, there are two aspects obviously in poison, one is the dose, right, and also the intensity, let us say, or the exposure, if I may say so, right. So, one is the concentration and other is the exposure. So, with that, I guess the greater the exposure time. So, even for low concentrations you are going to obviously observe adverse effects. So, but even at low exposure times, at high concentrations you are going to have different adverse effects. So, again high carbon monoxide can easily lead to what is it now, death. That is something to keep in mind, and sometimes there are irreparable damages to the neurological system. That is something to keep in mind too, right. Symptoms of carbon monoxide poisoning, again because of lack of oxygen or optimum levels of oxygen, dizziness, headache, and thus orientation, right, as I mentioned, cerebral function and such, right, which can lead to coma. Again disease of the heart and respiratory system, muscle weakness and cramps and such, again long term and short term aspects too. So, what do we have? Let us just look at some aspects out here. Typical levels of carbon monoxide, right. So, 0.1 ppm it is obviously, I guess, always present in the atmosphere. 0.5 to 5 average level inside the homes, 5 to 15 near the gas stoves in homes, but again keep in mind that mostly now we have LNG and such, that is why I guess it is relatively low. So, 100 to 200 ppm, ppm is parts per million, milligram per liter. It is near the exhaust from automobiles, but only those with catalytic converters, let us say. But now we are moving on to the remarkably, what do we say, high zone, right, where or which we need to be remarkably concerned about. So, exhaust from a home wood fire, right. You see the difference between cleaner fuel and what do we say, unclean fuel sources of energy, let us say, right, or poor sources of energy, if I may say so. But more importantly, this is relevant to Indian context because most of them do not have, or the vehicles do not have catalytic converters. You see it's 7000 ppm near an undiluted warm car exhaust without a catalytic converter, and the situation is aggravated near the traffic light stops and such. So, again, if you are in a traffic jam or your traffic light is off and such, turn off the engine, right, and I guess always wear a mask, corona or no corona, right. Again, carbon monoxide by itself, I do not think the mask will help you, but some particulate matter and such you can keep yourself safe from with the use of a mask. But again, do turn off your engine and buy better grade fuel and maintain your vehicle, I guess, right. So, before I end, as I mentioned earlier, we were going to discuss the book Anarchy, right, and I believe I mentioned that way earlier, but I was skeptical because obviously if I give out the whole details, the author can certainly sue me, right. But I think we can find a balance here. Again, the main aspect is that rather than just keeping the students interested, I also wanted to draw analogies out here between I guess if I may say recent past and our current what do we say or the future, let us say, right. So, again note that technology has been progressing, but people are emotions, greed for power, right, and money which go hand in hand and such, religion, all these interplays have always been out there, right. It is a huge potpourri out there, right. So, I just want to give a brief introduction about what we are looking at. So, I think in the year 1500 or so, when I think Shakespeare was what do we say, thriving in England, right, a small group of people came together, and when I read this, I guess it what do we say, raised the hair on my arms. Why I say so is that this building, which is going to be the headquarters of, or was going to be the headquarters of East India Company, British East India Trading Company, right, is like I think 6 windows by 6 windows, that is it, and that came to what do we say, rule over a vast what do we say and rich what do we say country, right. Again, let us see that UK, and they came together. Keep in mind that UK was not doing very well, and but India at that time was doing very well. Was it Shah Jahan or Jahangir, I guess, right. And at that time, at the height of Mughal power with respect to both culture, industrial production capacity and relative happiness, let us say, there at that time there was relative peace among the population, and with respect to religious what do we say, dependence or harmony too, right. And then I guess they formed a company and they took what is called shares, I guess. Each person paid an amount, and they collected a sum, and then they started this trading company. That was in 1499 or 1500, it looks like. And then initially they faced many reverses. Initially they were trying to get their spices from what do we say, the Middle East, right, Middle East, but again the spices were coming from India though, right. So, over time I guess they Spain, Portugal and such, they were fighting for this trade, source of trade, and piracy was actually encouraged by what do we say, the monarchy there, right, because that is a tool to gather wealth from the other country out there. Over time, I guess after some reverses, they were able to establish, again think of the entrepreneurship here, they sailed all around this here and were able to establish or get a trading post out there in India now. So, the first time this ambassador on behalf of British East India Trading Company went, I think, to Shah Jahan. Shah Jahan was again one of the greatest rulers of the world at that time, right. And keep in mind that he was a Saw gentleman, right, and his interests were not just mere wealth, but for the East India Trading Company, who were not doing very well, access to a prime what do we say, source of spices and other goods and raw materials, or even processed what do we say, resources like silk and such, that's was going to be a bumper offer for them, if I may say so. But Shah Jahan was more interested in culture and such. So, but again this was the start of what was going to be a tumultuous relationship, if I may say so. So, with that I will end my session, and we will continue this in the next session, and as usual thank you for your patience.